Welcome to BamfordRose and another question of the week. In this week's question of the week, it is: are GT4 or race style air filters worth it? The answer is no, and stick around because I'll show you some data to prove why they're not. Now, there's no shortage of these in the marketplace, whether they come from so-called professional retail outfits or it's an enthusiastic owner who can see an opportunity to sell you some parts. Now, what the GT4 style air filter does is take away the airbox, which I picture here, and replace it for something like this. So in this picture, we can now see the airbox as part of the entire system. So component 25 there is the air pickup pipe, and that sits in the middle of your grille, as you can see from my video here where I show it on this car. You've then got pipes 27 and 28, left and right side, which link into that pickup pipe. They take the airflow down to the airbox, and there you can see the lid, the filter, the main body of the airbox itself on both sides. You've then got the clean air pipe, component 6, which has got the mass airflow sensor in it, which then goes to a link pipe on the left and right side, components 2 and 3, which join into the Y piece, component 4, which takes it to the throttle body. So the idea of the GT4 inspired race filter is that you do away with component 25, 28 and 27 are two pickup pipes, and put your GT4 styled air filter directly on to the mass airflow pipe, which is pipe number 6. So you do away with the airbox, the air filter, the two link pipes, and the main pickup pipe in the middle of the grille. Now, in theory, these GT4 styled air filters should work because the race world uses a setup like this because it is going to be the best for performance. But in practice on the Aston, the air induction system is extremely well designed, meaning that a GT4 styled race filter is going to offer you absolutely nothing. But that doesn't stop the enthusiastic owner wanting to line his pockets with a product that offers the buyer absolutely no benefits, and it certainly doesn't stop professional outfits pulling the wool over people's eyes either. So let's put some data to those claims. When I was on performance development for the V8 engine originally, when it was 4.3, the 4.3 V8 engine at maximum airflow can actually flow all the air it needs at the red line at peak power through just one airbox. However, because that is a considerable volume of air going through one filter, it would mean an incredibly low service life for that filter. You probably have to be servicing, changing the air filter every 3,000 miles or so. So to get the service interval of the whole car up, 2 airboxes were added to increase the service life. The 4.7 flowed a little bit more airflow at peak power, and probably one airbox alone wouldn't suffice for the airflow that the 4.7 needs. So I got the laptop connected to the OBD port to measure some parameters, and we selected third gear, and we selected a start data recording point of 3000 RPM and a finish data point at 7000 RPM. In third gear, those two start and end engine speed points represent approximately 38 starting miles per hour and 90 miles per hour ending. That means that with the draggy, we can measure how the car actually performs in terms of time, And with the engine management system data, we can actually measure how long it took the engine to rev up and what the actual airflow was. Meaning that we have two absolutely conclusive data sets to prove our point. Now, obviously, this was recorded on track, and it's my own car before people start saying, oh, you're using other people's car to take pictures and do tests with. So if I'm perfectly okay to blank the air filter box off on my own car and run one air filter, then it just goes to show that that's perfectly safe. So here's the recording of the draggy, and here's the camera looking at the engine management system data. Now, what you can do if you don't believe the summary of my figures is play it in slow-mo and write down the figures for yourself.
We'll start
quarter mile
when I hit 40, yeah?
Yeah. So now we can conclude that data log with a little table that I'll flash up on screen now. So this is with both airboxes connected, so a completely standard car. So the draggy said that we started our timed recording at 38 mile an hour at 0.04 seconds, and we finished at 90 mile an hour at 0.12 seconds. So that is 8-second duration to complete that acceleration. If we now look at the engine management system data, that start point was approximately 2,772 RPM at 54.27 seconds, and we finished at approximately 6292 RPM, which is approximately 61.57 seconds. So the engine management system data was saying about 7.4 seconds to complete that acceleration, and the draggy was saying about 8 seconds. Now, if we look at the table of data, we can see something really interesting here. So the engine management system, being a Ford unit, is in imperial measurements, and we've got manifold absolute pressure there of 30 inches of mercury. Now, 30 inches of mercury is 1015 millibar. So that data set tells us something very interesting. You know, I'm a performance development engineer, and this company sells performance products. So if you do a power curve on an engine and you measure the total exhaust system back pressure, then there is going to be a restriction in the exhaust system because of the catalyst. The exhaust back pressure will be high, and if you remove the catalyst, you'll lower the exhaust back pressure, and just because of a lower, less restrictive system, you're going to get more power. So as soon as an engineer sees quite a high exhaust back pressure figure, he's going to be thinking, well, there's an opportunity for me here. I can see a product that I can change to give more power, and I can sell that as a performance product. If you were to do the same power curve on the inlet system, as you can see from this data here, the pressure measured in the inlet manifold is exactly the same as atmospheric. That means that no matter what you do to the air induction system, you won't realize a performance increase because there have been no losses across the system. So for instance, if a particular airbox had to be designed in a way to limit induction noise because there was a lot of induction boom and that failed noise drive-by testing, then the automaker would have to come up with an airbox that was very restrictive, and then there would be a lower inlet manifold pressure compared to atmospheric. So then the performance development engineer who wants to sell some components in the world of aftermarket can come along and revise the induction system so that when you do a power curve, the inlet manifold is more or less atmospheric pressure. But as you can see on this data set, already the inlet manifold is atmospheric pressure. Now, most engineers who know what they're doing are going to immediately look at that data set and say, well, there's nothing to see here. I can't improve on that air system. I can't make the inlet manifold run greater than atmospheric pressure. So there's no point touching the airbox system at all. The reason the airbox system on the Aston is so good is because the car allowed for a fantastic installation without restrictions. It's got the big airbox in the wheel arch liner behind the wing. It picks up the air from the front of the grille, which is super cold or atmospheric air, so it's not subject to heating up in the under bonnet area, as happens on some cars. So from the moment the air comes in, it's allowed to pass through unrestricted trunking because it's so large. It then gets fed through the air filter, which is quite large, doesn't offer a restriction. It then gets passed through the mass airflow sensor, up into the Y-piece, up into the inlet manifold, meaning that the air is atmospheric temperature and the pressure of the air is also atmospheric. So just because Aston didn't have to bunch up that air induction system in the under bonnet, where it was subject to hot temperatures and maybe contorted pipes causing restrictions, means that Aston were able to achieve an absolutely perfect air induction system. But let's not let the data stop somebody from selling a component just because it looks like it should do the job. You know, of course a race car is going to have the GT4 style air filter. It's because in a race car you're not going to lug around all of those components that the road car needed. So you take off all the unnecessary road car stuff and put on your race stuff. It's just in this instance the road car stuff was that good that in terms of performance the GT4 style air filter offers nothing other than a few grams of weight save. But if you're a moron who doesn't realise that, hasn't conducted the test, you can put some shiny nice pieces of motorsport kit on a table and people who are uninformed will buy it. So now on this video you can see how I blanked off the air induction pipe to the passenger side airbox of my own car. So this now means that all of the combustion air supply is running through one air filter box up into the Y-piece, up into the inlet manifold. Here's a recording of the acceleration in that car. Again, it's exactly the start and finish endpoint in terms of engine speed measured by the engine management system and vehicle speed measured by the draggy. So we've run the draggy test, and with one airbox only, we started at 38 mile an hour at 0.08 seconds, and we finished at 90 mile an hour at 0.15 seconds. On the engine management system data, we started at 2607 RPM at 29.92 seconds, and we finished at 6177 RPM at 38.03 seconds. Now I'm going to get some test-to-test variability. What that shows is on the draggy that we actually did that 38 to 90 mile an hour acceleration in third gear a second quicker on one airbox than we did on both airboxes. And on the engine management system data, it shows that our start and end engine speeds were 8.1 seconds on the one airbox and 7.4 seconds on both airboxes. So as I say, you get some test-to-test variability in all of these things, but between both airboxes fitted and only one airbox fitted, you can say that both the vehicle speed acceleration run from 38 to 90 mile an hour was the same on both airboxes, and in terms of the engine speed start point and finish point, it was a little bit quicker with both airboxes, but it's about the same. More importantly, if we go to the table of data, what we can see here is that low speed with one airbox, we do start at 30 inches of mercury, but we drop down to 28.2 inches of mercury at 6,177 RPM. So what that is showing there is that at peak engine speed with one airbox, there's starting to become a little bit of a pressure differential, a restriction, because inlet manifold pressure is now slightly lower than atmospheric pressure. But that 1.8 inches of mercury pressure loss didn't really cause us an vehicle speed or engine speed time difference. Now, what that test is showing isn't to preserve your air filter life and go and block up one side. What it is showing is that you can perfectly well operate and get maximum airflow through one airbox system. So even if you're not mechanically minded and can't think these things through technically, what you can say to yourself is, well, if I completely remove one airbox and flow all air through one airbox and still get the same performance, does removing two filters and replacing them with GT4 motorsport style filters going to give me any performance increase? The obvious answer is no, because you can flow the air through one airbox running a standard filter. But not just is the GT4 airbox modification pointless for performance, then it also offers a couple of detriments that aren't too great either. If you go back to the schematic of the air induction system, then you can see that there's a MAF meter on each clean air pipe. Now, if there was ever an airflow imbalance measured between the two sensors, then it's going to shut you down on an implausible airflow signal. When the air pickup is from the center of the grille, it sort of evenly distributes air to both airboxes, meaning that you're unlikely to encounter that airflow imbalance. If you did away with that center piece trunking, which the GT4 airbox does, and you had a gust of wind coming from one side as you were driving down a motorway, then you're likely to get an increase of airflow through one MAF meter and you'll be shut down. So getting rid of that center pickup is not a good idea. It's also not a good idea because the faster you go, you will get some ram air effect through that center pickup. If you take away that center pickup, you've completely destroyed the ram air effect. So even though the GT4 air filter in a motorsport environment might be better for weight, you've actually got no ram air effect to help performance. Another reason why it's a bad idea is because if you see the air pickup point in the grille, then that means that if the car was wading in water, then the water level has got to be extremely high to get into the air pickup pipe. If you've got a GT4 style air filter that is basically in the inner wheel arch area, that's very, very, very low and is susceptible to suck up water. It takes a very small volume of water for these engines to hydraulic. You know, the combustion chamber volume is only about 40 cc's. It's a very small amount. So if you pick up even droplets of water, not wading through deep water, maybe you splash through a puddle, if you're very unlucky, that's enough to hydraulic one of these motors. So there you have it. A complete summary of, are GT4 air filters any good for your Aston? The answer is no. All they're good for is lining the pockets of the people that didn't do the research to see if it was actually worthwhile to design and develop it in the first place. Hope you like that question of the week. As always, it really helps us if you could subscribe to the channel, click us a like, give us your comments on GT4 air filters. No doubt it will raise as many comments as superchargers do. Until the next time, when we see you on Question of the Week.